Behavior of bolted joint. So far in this second module, we have discussed regarding what is bolt, what are the types of bolt available, what are the code books which is relevant to the bolt, the advantages of bolts, and now we will be looking into the behavior. When you are using a material, you should know how many types of similar materials are available and what is the guideline which is given. These two things you should know, and after that you should study the behavior, that is how it fails, what are the possible failures you have to study, then you can design. For the design subject, it might be concrete structure or steel structure, the subject moves like this. Without knowing the material, you cannot design. Designing is a process, so that is why I have informed you in the first class what are the design processes. First you have to know the material property, analysis, and the climatic conditions, environment, everything. If you are getting an understanding, then you can go to the next step called design. So before any bolt design, you should know how this structure is going to fail, how the bolt is going to fail, or how they are going to perform when load is acting. Without load it is different, but with load how it is behaving, we will be looking into today's class. The possible limit state or failure modes that may control the strength of bolted connection may fail in the following modes. So these are the modes of failure. See, when you are designing any section, you will be having a plate and or a member. It might be an L section or it might be a C section. You will be having a member. That member has to be connected. So there might be shear failure and bearing failure. These are the two types which are encountered. First one is shear. When it will be occurring is whenever you have any member which is having bending force. So along with bending, shear will be there. The failure might be shear failure of plate or shear due to bolt. So due to any one condition, the structure may fail. So this is an example. So I will show you here. See, there is first plate here, and this is the connected plate, and in between two plates a bolt is being connected here. What can happen is this bolt can shear and it can fail. That is, you can see the single shear here. If two forces are applied, one force is here and other force is opposite to this direction. So this is the case. When two opposite forces are acting, what will happen? The bolt will be getting the shear force and it will be taking the shear force, and it gets sheared, and it is the first mode of failure. Okay. Not only the bolt can shear and fail, the plate itself can fail. So here you have two number of plate, the plate can also fail. So this is given in the next figure which we will discuss. The shear can be at bolt or the shear can be at plate. Okay. Next type of failure is bearing of bolt and bearing failure of plate due to incapability of taking the load. This kind of failure will be happening here. Yes, you can see the example of this. First example is shear failure. So what will happen? This member, this plate will be going left hand side and other plate will be going right hand side. So due to this, the shear will be there and the bolt may fail, and this kind of failure is known as shear failure. The shear failure due to plate might happen. What do you mean by plate is, the bolt might be working fine and you can see the bolt will be at the axis and you can see the failure at the plate. So this kind of failure is known as shear failure on the plate. The two equal and opposite forces are acting, but the plate is being failed. So if you observe any steel structure fails like this, it is called to be shear failure of plate. And next failure is bearing failure of bolt. So the bolt can fail by this action called shear, and it can crush. So this mode is called bearing failure. For a plate, if the bearing failure occurs, what will happen? There will be warping in the plate. So you can see this kind of warping in any plate. So this is due to bearing failure. The plate cannot handle the load. So what is the load acting here? Either tension or compression. Tensile force. So this tensile force cannot be taken by the plate, which is known as the bearing failure. Okay. Now you have tensile failure of bolt and tensile failure of plate. So this is the next type. You can see tensile failure of bolt is if the bolt is being applied tension here. See, can you find the difference between these two forces? The bolt is being applied a force in the shear mode, and if you are applying the force in a tension mode in the bolt, what will happen? The tensile failure will be happening. So it will be elongating and it fails. And if the tensile force is acting on a plate, it will be failing with the rupture along the direction. So this is the line of action of force. It fails in the perpendicular direction. If the force is acting at two direction, the failure will be acting on the perpendicular axis. So this type of failure is known as tensile failure. So one of the student in your class have sent there was a brick failure in some construction. So the brick failure was all the bricks is being having the cracks. So if this is in the case, if this is the brick, there was a crack across this brick. Those kind of failure is called tensile crack. In a brickwork, you will be having the force which is acting on the horizontal direction. If the force is perpendicular, your failure will be horizontal. So this kind of failure is known as tension failure of a plate. And final failure is bending failure of bolt. You can see the bend of a bolt. If two forces are acting equal and opposite direction, this creates shear and you might have bending also. So the bolt might bend and it can fail. So these are the four possible types of failure, that is shear, bearing, tensile and bending. So these four types is important in bolt. So before going into design, you should know some of the elements of bolted connection. So this is known as lap joint. I have already discussed. If you have two plates and it is being connected by a single or double bolt, so this can be called as a lap joint. What do you mean by butt joint is, if two members are there or two plates are there, you will be adding additional plates, and from this additional plate you will be joining with a bolt. So this is called the butt joint. The another type is eccentric shear connection. What do you mean by that? You have a bracket. So this member is called a bracket and this is called column. So in a column you will be having this kind of bracket plate. It will be bolted in this direction and the beam will be placed here. In gantry girders you will be seeing this kind of brackets. So if the beam is placed here, what will happen? Here you will be having shear. So one force will be acting downward and column force will be acting upward. Here comes the shear, and the shear is eccentric here. It is not along the plane, it is eccentric. It is away from the object. And this is the eccentric shear connection. And tension member connection is you are having a beam here. Below that you have the connection member, which is structural T. This is called tension connection and combination of shear and tension in connections. These are the example of truss. The truss might be Yes. See, this kind of truss members are there. If you are connecting in a truss member, you will be having combination of forces. First, you will be having either tension or compression here, and this has to take the tension or compression force along with the bending. If the structure is handling any bending force, it has to take more than two number of forces. So this is known as combination of forces. Yes. So this is the example of the connection, combination of shear and tension. If the tensile member is connected in a plate here, so this gusset plate will be taking the load. So here you will be having the bolt. So the line of action of force is different, and here you will be having tension and shear. Also, when the beam is connected like this is a column and beam, you are having an angle section. If it's connected by the bolt, you will be having two force. What are they? Here you will be having shear and the bending. So these are the two combination of forces. You can provide a angle section in a column. You will be having the similar two combination of forces. So this is the example for butt joint. The two plate members are here. This is member number 1 and 2. You can see additional plates they have provided at bottom as well as in the top. So at both the portions they will be providing the plate. In some cases they might only place the bottom portion only for connecting. So these are all known as butt joint, and the eccentric shear connection will be like this, and web angle connection. This is a beam. So you have beam along the two sides. Along the web of the beam, the connection is being made. This is known as web connection of a beam. Bolt forces, we can split it out, and you can see both shear and bending will happen. If the force is along this direction, only tension will not occur, two forces will be occurring. What are they? Shear and bearing at a joint. The force might be single. Whenever you are designing, always the bolt is designed for bearing force. First step will be bearing stresses, and second step will be shear stresses. So you have to check the shearing strength and the bearing strength. If both are okay, then your bolt is safe to proceed. In the design, you will be having these two steps. Okay. The plate forces. If the forces are there in a plate, either the plate might have bearing or friction. So the bearing will be there on the member, and friction will be there in between the member. If see you have three number of plates here, and in between two plate you will be having the friction. So friction force will be acting in between the two members, and bearing force will be occurring on the plate. So this is the different. And if the purely tensile force is acting, so you have two plates here and it is being bolted, the force is along the axis. So this kind of force will be having purely tension in a bolt. So whenever you are designing a bolt, you should check that where is the plate connected. If the plate is connected like this or like this, so they will be giving in the problem. And second thing what you have to check is how the forces are acting. Is the force acting along the bolt or perpendicular to the bolt? So you have to check these two. If it is acting not on the axis, so you have to check for shear and check for bearing. If the plate is being used, you have to check for the bearing of the plate. So these three are important. If they are giving in a problem, use high strength friction grip bolt, they will be asking in a problem. If they have mentioned the term called friction, then you have to check for what? Frictional force. If they have not given in the problem, you should not check for the frictional force. Okay. Now you take down the next component, simple connections. Truss joint connections, connections at beam column junctions. It might be seat angle, web angle, stiffened seat angle, and header plate connection. So this example is given already. if any beam is connected with a column. So if it is provided at the bottom, it is known as what connection? Seat angle connection. If it is provided at the top, cleat angle connection. So this is what they have given. Connection between beam column junction, if it is provided at the bottom, it's known as the seat angle. What do you mean by web connection? The beam and column will be connected in. Can you see this? This is known as what kind of connection? Web angle connection. So what do you mean by this? In a beam, this portion is called web and the top portion is called flange. If your web is being connected by an angle section, this is called as what? Web angle connection. What is single bolted lap joint is? If you are having only one row of the bolt, it is called single bolted lap joint. If two plates are there, only it is being connected by a single row of bolt, this is called single bolted lap joint. If you are having two plates and two rows of bolt, then it is known as double bolted. Okay, if you have eccentric in lap joint, so it will be taken in terms of E here and single cover butt joint. So two plates are jointed at the ends, which is covered by the plate, which is called single cover butt joint. So you have two rows of bolt in a plate, hence it is double bolted single cover. If you provide at bottom as well as top, it is called double cover butt joint. Here it is only connected in a single row, hence it is called single bolted double cover butt joint.